Lesson 3 is going to have a lot of information about chords, not a lot of examples about chords. So one of the dangers here is that you get all the information and you don't really think about it. You just write the things down and you just have the information. It's just like if you were just reading it in a book, which is great, that's fine, but we also want to make sure that you understand why these things are true so you can think creatively about how to apply them. Because there's so many different ways in which we can approach using these in our work for this and other classes and other other professions, et cetera, et cetera. And so what I want to focus on with chords is just making sure that we can relate chords with central angles and arcs. All right, so we already know the relationship between central angles and arcs. That was established on our first day of this unit, but we want to connect that to the chord that is the segment formed by the endpoints of the arc. All right, and so here we have arc PQ. We've got the central angle POQ, and this angle's measure and this arc's measure are the same measure, right? We know that from our first lesson. Well, this segment that connects P to Q is called a chord. It is called a chord of a circle. All right, and so it's just a segment whose endpoints are on the circle. That's basically it, but that chord is specifically tied to the arc PQ and the central angle POQ. That's really important that we make these connections, not just, hey, it's a random segment, but it's connected to things that we already understand. And if we can make that connection, then things will go more smoothly for us. Obviously, I can tell you other things, you can write other things down, but if you're not thinking about what the relationships are, then this is all a moot point, because this is just stuff that you can just read on your own. All right, so segment MN and segment PQ, if these segments are congruent, then that means these angles are congruent, and here's why. If these segments are congruent, we already know that these radii are congruent, and so we have two congruent triangles by side, 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 and therefore by CP, CTC, those angles will be congruent. These aren't vertical angles, but those angles are congruent. And so that takes us then to the next step, which is that these intersected arcs will also be congruent to each other. If two chords are congruent, if I have another chord that I'm going to draw right here, and if I say that this is congruent to those, then I know that this arc is also congruent to this arc and to that arc. They're going to have the same length. They're going to have the same measure. All right? The converse of this is also true. If these angles are congruent, then that means that these chords have to be congruent. And the converse of that is proved using side angle side. If these triangles are congruent by side angle side, then that means that these parts are congruent by CP, CTC. So MN would be congruent to PQ. Right, so those are facts. Maybe you need to write a fact card where you write down all of these fun facts about chords. All right, maybe for a better teacher, I'd make you do that for like points or something. All right, theorem 5 and its converse. If we have two chords that are equidistant from the center of the circle or of congruent circles, then it means that these chords are congruent. This is a little tricky of a proof, but if this distance is the same as that distance, then what that means for us, remember this is not a radius, but if SE and SF are congruent, that distance from this point to that line, then when I draw in a radius, I'm going to make congruent triangles by hypotenuse leg. Right? Distance, we measure that distance from a point to a line or a ray or whatever by using, it has to be at a right angle, right? That's how we measure that distance. The distance from the top of your head to the ground is how tall you are. But we don't measure that at an angle, right? We measure that when you stand up straight. Right? So that's how we know that these are right angles. So here we have hypotenuse leg, triangles are congruent. And so that means that this piece here is congruent to this piece here. Furthermore, and we can extend that out, then this triangle is going to be congruent to this triangle, to this triangle. All these triangles are congruent to each other, which means that this whole piece is congruent to this whole piece. All right? And so conversely, if we know that these chords are congruent to each other, then also they're going to be equidistant from the center. All right? That proof shouldn't take us too long either. So I want you to make sure that you see the connection. If these are congruent, then that means that these are congruent as well. Theorem 10.6. If a diameter is perpendicular to a chord, then it cuts the chord in half. Now this would be much easier to explain if we were in Unit 5, because we actually proved that in Unit 5, but we skipped Unit 5 this year, and so I don't know where we're at with that. But frankly, we would have, again, side angle side, with the right angle being congruent to the right angle. Oh, I'm sorry, that's me proving that it is, that's the converse, all right, proving that those are perpendicular. If I know that they're perpendicular, then we have side angle side. These triangles are congruent, and therefore, because we would have, actually, I'm sorry, hypotenuse leg. We would have hypotenuse leg congruent. PB and PA are congruent. This part is congruent to itself, and then right angle. So hypotenuse leg, that means that this piece is congruent to that piece, because those two triangles are congruent. All right, now the converse. Sorry, I kind of got muddied the waters there. If we know that this is a diameter, so it has to go through the center, that's really the whole point of this, then, and we know that this is congruent to this, so we are going to prove that these are going to be right angles by showing that we have side, side, side congruence. The radii are congruent, this part is congruent to itself, and then these parts are given congruent. Then that means that these triangles are congruent, and these angles that are supplementary and are congruent must be right angles. If those angles are supplementary and congruent, then those angles must be right angles, because if it's x degrees and x degrees equals 180, then 2x equals 180, x equals 90, right? We proved that back in Unit 1, back in August, September. All right, so here, if we have a chord cutting through, a diameter cutting through another chord, then it is perpendicular to that chord, and it bisects the chord. All right, so that's really important to recognize. All right. Now, the last part is an extension of that piece right there. If you have a diameter here cutting through a chord at a right angle, we know that it's going to be bisecting that chord. So here's this question. The perpendicular bisector of a chord in the circle must contain the center of the circle. All right, this is kind of a neat trick, that if we are cutting this segment in half, then we can prove that the center of the circle is on that segment that bisects our chord. That's the perpendicular bisector of the chord. Right? The extension proof here is going to be a little bit muddy, all right? A little bit muddy, but it is work that we can do, and it is proof that we can undergo. Showing that these segments, knowing that these segments are congruent, knowing that these are right angles, knowing that this is congruent to itself, that means that these segments are congruent, and therefore they have to be radii, all right? It'll be the center of the circle. And S is the center of the circle. All right, so these are all of the theorems. It's all these fun facts. I don't know how fun they are, but these are all fun facts about chords, how they relate to the arcs, and how they relate to the angles. We want to make sure that we connect all of those dots in our conversation and practice in class. So this is going to require me to do some of the items and then set you free to follow those examples as we work. And then there will obviously be some questions where you get to think through them as well. So hopefully you can connect the length of a chord to the measure of the central angles and the arcs that are intercepted.